So, so if I'm reading the chart, I'm not reading the chart, but if I'm reading the chart, I'll find the area from 0, which is 0.5, and find the area from negative 1.25, subtract, and get the remainder. But I'm going to pull my calculator up, so I will get my calculator right now. And then put in the numbers in here. So before I put in the numbers, I will make sure that, all right. So I want to make sure that I write the argument that I'm going to give my calculator. So the argument I'm going to give my calculator is going to be find the area. Because this area, it is normal cumulative density function, lower bound, upper bound, the mean, and standard deviation. Standard deviation. Okay, this data is already standardized, so it's not a raw data. The mean of a standardized normal curve is 0, and the standard deviation is 1. So I'm going to quickly write normal cumulative density function. The lower bound is the smaller number, negative 1.25. The upper bound is 0. The mean is 0 too. The standard deviation is 1. So I'm told to find the area between negative 2.5 and 0 in a standard normal curve. So I just want to make sure we remember where to go. So do we remember where to go when I'm finding the area with my calculator? I will do second distribution, number 2, and then the lower bound is negative 1.25. The upper bound is 0. The mean is 0. The standard deviation is 1. So I am going to paste, and my calculator is asking me, are you sure that this is what you want? Yes. So I hit enter. Let me see. So it says quit. That means there is something. Okay, there are two. So I'm going to delete that, and I'm going to arrow to the right and see if there's any other. Okay, I'm going to enter again. Tell me that the area is 40%. Just, we need to remember that area cannot be negative. So there's no way you can get an area. It doesn't matter how, area can never be negative. So area under the normal curve is always positive. So that says that the area between is 40% of. So I am just going to write this area is 0.4. The area is 0.4. Okay, this is area between. So let's do area to the right again, just so you will remember how to do them. When we get to unit chapter 7, which is going to be the first thing we do next week, we will actually start with normal distribution. Okay, so number 10 this time. The first thing is to draw a normal curve. So draw a normal curve and shade the area you are told to find. Not supposed to touch. This is not supposed to touch. Okay, 2.53 is greater than the mean, so it's on the right hand side of the mean. So 2.53. This time I am looking for area to the right because they told me that z is greater than 2.53. And this tail is going to positive infinity. So I have 1e to the power 99. Okay, then I'll write the argument for my calculator. So for area under the normal curve, normal cumulative density function, starting from 2.53. So this is area to the right, going to positive infinity. The mean is 0, the standard deviation is 1. So this is what I'm going to tell my calculator to find the area. So the shaded area is that. So I'm going to put my calculator up and put it in. So find the area under the normal curve in the shaded region. Find the area in the shaded region. Okay, so I'm going to clear. Now I have my calculator here, and I want to find normal cumulative density function. We usually know it is second verse, and then we're looking for cumulative. So number 2 area is cumulative. And then I'm starting from the lower bound, the smaller number, and the smaller number is 2.53, 2.53. And then the upper number is positive infinity. So 1e to the power 99. We should not forget that e is under comma. So second comma to the power 99. Arrow down. The mean of a standard normal is 0. The standard deviation is 1. So I'm going to paste. My calculator is asking me, is that what you want? Yes, that's what I want. So I'm going to enter to actually, that area cannot be 0. Let me find out what happened. Yeah, it's saying it's almost 0, but it means that let me go to mode and see what okay. I'm going to reset my mode to float. The reason why I want to reset my mode to float is the area can be in decimal. So I'm going to do it again, second quit. All right, so I hit second enter, and then I'm going to hit enter. So that area is almost 0. It's 0.006. In other words, that area is 0.6%. If I'm told to change it to percent, the area is 0.6%. Alternatively, I can say that the area is 0.0057. So that area is 0.0057. 0.0057. The shaded region. Area from 2.53 to the positive infinity. And so if I'm looking for area, I can change my decimal, my float, number of decimals to 4. All right. Okay. And so we found area to the right. Next, we find area to the left. I want to make sure that we know how to find area to the left also. Number 11 is find area to the left. Our test is going to be on Tuesday. It's going to start on Tuesday and start on Monday and finish on Tuesday. Okay. All right. So, number 11, we are told to find the area under the normal curve when z is less than negative 1.25. So first thing is draw a normal curve. First thing, draw a normal curve. So we have done area between. Then we have done area to the right. Now we are doing area to the left. So area to the left is what we're doing now. You again draw a normal curve as usual. And then I'm given the left, the minimum number is negative 1.25, Negative is less than the mean, so that's Z is negative 1.25 about here. I have to shade the region I'm looking for. I am looking for the region at the tail, area to the tail. My calculator does not understand the negative infinity, so I'll put in negative 1e to the power 99 there. Then I will tell my calculator, I'm going to write the argument. So write the argument that so normal CDF, starting from the lower bound, and the lower bound is negative infinity, negative 1e to the power 99. The upper bound is negative 1 is negative 1.25. The mean is 0, the standard deviation is 1. So I'm going to calculate. So I will calculate. Now that I'm going to calculate, I pull my calculator up and I am going to go to distribution. Where do I see distribution? Second verse. And normal CDF is number 2. Okay, the lower number is negative infinity. So I put negative 1 e to the power 99, e to the power 99. All right, then the upper bound is negative 1.25. The mean of standard normal is 0. Standard deviation is 1. I'm going to paste. So when I paste, I have that area is approximately 10.56%. 10.56%. So I can just write 0.1056. So if you're told to leave your answer in percent, then you can convert to percent. So we have found the area. All right, so let's find the area to both tails this time. So all the scenario we are trying to do. The scenario area between, the scenario area to the right, area to the left, and area to the tails. So in question number 14, it's asking find the area to the left of negative 1.54 or area to the right of 1.54. Anytime I have this kind of question, I remember that the normal curve is symmetrical. So if you know that, you're going to shed two tails. So I'm going to shed two tails. All right, so, and this is negative 1.54, and this is 1.54. The absolute value of these two numbers are the same. Therefore, the area will be equal. The normal curve is symmetrical. The absolute value of negative 1.54 and 1.54 are the same. Therefore, we're going to take advantage of the symmetry, normal curve symmetry. All right, so let's do that. All I have to do is find the left side and multiply it by 2. So I'm going to find the left side. This is going to negative infinity, negative 1e to the power 99. All right, so normal CDF. I have negative 1e to the power 99, comma, got negative 1.54, comma, this is a standard normal curve, therefore the mean is 0, standard deviation is 1. So I'm going to find the area to the left. When I find the area to the left, I multiply by 2 because normal curve is symmetrical. All right, so I'll get my calculator and put the information in. So I'm going to clear. Okay, so, and then I will go to second verse, number 2. The lower bound is -1 e to the power 99. It's already in there. And the upper bound is -1.54. So I can actually change 54 here. Okay. And the mean is 0, standard deviation is 1. And I'm going to paste. And my calculator is asking, is this the argument you want? Yes. That's the argument I want. If I hit enter, it gives me area to the left. I'll take 4 decimal points. So the area to the left is 0.0618 approximately. 0.0618. And then, because the normal curve is symmetrical, area to the right is also 0.0618. I'm told to find OR, so I can add them up. OR in probability means addition, though. We have said that. OR in probability means addition. So whenever you're told to find the probability of area on the normal curve, z less than, z greater than, it means you're supposed to add them up, because OR in probability means addition. Okay, so we're going to add this up, and then I have, I can just actually multiply it in my calculator. See how we here? So multiply by 2, multiplied by 2. So I'm getting to my multiplied by 2. And I got what? 12.36% approximately. So that is the area on both ends. So the area on both ends is that. Okay. We may not actually use the whole day. We just have to finish some stuff, and then we are good for the test. All right, so number 15, what is the total area underneath the normal curve? We already said that, but it's good we say it again. The total area under the normal curve is 100%, or 1, or 1. The total area under the normal curve is 100%, or 1. What percentage of the area falls above the mean? Above means greater. The percentage of the area above the mean is 50%. Question says percentage though. So it cannot, it says what percentage? So you have to write an answer in percent. The mean divides the normal curve into 2 congruent parts. So the percentage above the mean is 50%. The area under the curve for a normal distribution is 1. Is it true? Yes. The area under the normal curve is 1. All right. Number 18, the mean, mode, and median, this is supposed to be median, are all equal for a normal distribution. Yes. The mean, median, and mode are equal when the data is normal. Number 19, the area under the standard normal curve that lies within 2 standard deviations from the mean is approximately 95. Is that true? Yes. This is true also. Okay, a distribution is said to be positively skewed if the mean falls to the right of the median That's not true. Anyway, it's a mistake that the mean falls to the right of the median. I haven't even looked at this. The mean falls to the right of the median. When the mean falls to the right of the median, then data is positively skewed, and that is true. Okay. All right. So these are easy questions, but people still fail these easy questions because they forgot or they didn't pay attention. They still show up in final exam. Let's see. Okay. When we finish this, we are going to be good. Okay. This one says find the probability of Z occurring in the indicated area. In other words, the first one, this is area between. This is area between. So you have to write it. Normal CDF, area between 0, 2.25. And then because it's a standard normal curve, you get the answer. And this is symmetry again, the symmetric property of normal curve. So the absolute value of Z on both sides are equal. Therefore, when I find the area to the left, I multiply it by 2. So I can just do that. I can pull my calculator, find the area to the left, and multiply by 2. All right, so find that area to the left. By the way, I have to write it. So I'm going to write the argument. It's area to the left, so I have normal CDF. Starting from negative infinity, stopping at negative 1.29, where the mean is 0 and standard deviation is 1. So all right, so now I'm going to collect second distribution number 2. So the lower bound is negative infinity, and it's still okay with the, and the upper bound is negative 1.29. So I can go here and change 1.29. And the mean is 0, standard deviation is 1. It's a standard normal curve. So I'm going to calculate. So the area is 9.85%. If I'm told to find my answer in percent, if I'm told to leave my answer in decimal to 4 decimal places, I will have 0.0985. 0.0985. I hope we don't have any question. All right. So making sure that we know how to answer those questions.